In this video, we are going to continue with our application of permutation. So let's begin. Now, these are other applications of permutation. So here you have four boxes: box 4, box 3, box 2, and then box 1. So these are four boxes. They are distinct. Very, very important. They are distinct. It means each of them is different. None of them is the same. Therefore, since they are four, we only have to take the number. So the total number is 4. So we take 4 factorial, and as I said earlier, that will be 4 times 3 times 2 times 1. So that will be everything. So 4 times 2 times 4 times 2, 4 times 4 4 times 3 is 12, times 2 is 24. So you have 24 possible ways that these boxes can be arranged. 24 possible ways that these distinct objects or boxes can be arranged. Please, very, very important, for you to use this permutation, the object must be distinct. They must be different. None is the same. None is the same as the other. They are different. So let's proceed and solve some questions. So in this example 2, in how many ways can 5 different books be arranged on a shelf? So the key factor here is different. So different ways. So that's 1, and then 2, there are 5. So because R is 5 and then N is also 5, it means that you can take your permutation. You can take your 5 take one of them and then find the factorial, and then here you have your 120. The same thing applies here. So here in the race, 8 runners. In a race with 8 runners, how many ways can gold, silver, and bronze medals be awarded? Now, you realize that here you are taking a total of 8 runners, and then you are going to share between them this. So how can they share between 8 people? So it means that your permutation is going to be, the total number is 8, and then the object that you are selecting, you have selected gold, silver, and bronze to be awarded to the runners. So those are the selection. So your R is going to be 3 here. Your R is going to be 3. So your R will be 3, and then you write your permutation. And as I said, what you need to consider is that now there are 8 people, and then you are going to share 3 items or awards to. How many people will be left without having it? That will be 5. So the total people, or the total runners, factorial of the total runners over those that wouldn't get the award. In this case, if you are to share to 3 people, then 5 wouldn't get. The award is only 3, so it will be left with 5 people out of the 8. So you divide that by 5 factorial. So that's the basic concept. Always, how many is the total? How many is the total number of people, item, or object that we are taking under consideration? Then how many people are we selecting out of that? Here we are selecting only 3 that we are selecting. So how many people will be left without getting the award? That's how you have to perceive it. How many people will be left without getting the award? So 8 minus 3 is 5. Therefore, you divide the total, you find the factorial of the total. In this case, is 8 divided by when the 3 is subtracted from 5. When 3 is subtracted from 5, so it's subtracted from 8, you get 5. So that's what you get for this one. Then you find your factorial. As I said, all the positive integers that are less than or equal to the number. In this case, we have 5 factorial. Now, what this means is that why they have this is that 8 factorial is equal to 8 times 7 times 6 times 5 times 4. Now all over 5 factorial. 5 factorial is also 5 times 4 times 3 times 2. So you realize that from 5 downwards, everything from 5 downwards can cancel everything here. That's why they chose to write 8 times 7 times 3. 8 times 7 times 3. So that's how they got 336. 336. That. And also another application is of permutation is creating codes, password, numbers without repetition. Once again, without repetition. No number is repeating before you can apply this concept or this formula that we are using. Now, let's consider this example. Let's consider this. You realize that there are three distinct balls. We are considering this area. We have red, yellow, and red, blue, and green. There are three distinct balls. So since there are three distinct, it means that we can, the first choice will have three possibilities, the second choice you have 2, and the last choice you have 1. So the total is going to be 6. Now let's see what is really happening here. Then we compare that with the combination over here. Let's see what is happening here. What is happening here is that the first scenario,